Okay, this is section 4-7, using CPCTC. This is going to be really similar to 4-5, it's just that the problems are going to be a little bit more complicated. There's going to be actually 2 steps to them. This is my all-time favorite section, so because it's kind of like a puzzle. Alright, a couple of things to remember before we begin about CPCTC. Things to remember. Number 1, never use CPCTC to prove triangles congruent. Remember, CPCTC was used to prove their parts congruent, not the triangles themselves. The triangle congruence theorems and postulates are ASA, AAS, SAS, SSS, and HL. But you do not use CPCTC to prove triangles congruent. Okay? Never use CPCTC before a triangle congruent theorem. It always comes immediately after. Go back and review 4-5 notes if you've forgotten this. You use a triangle congruence theorem to prove the triangle is congruent, then its parts are congruent because of CPCTC. Remember that P stands for parts, and it always comes after one of the triangle congruence theorems. Okay? Alright, I'm going to go ahead and get a straight edge to draw the pictures today. Okay. Alright, so like I said, this isn't anything new. You've already done CPCTC, but the pictures and the proofs themselves are going to be just a little bit more complicated. In fact, you're going to have more than one triangle going on in this case. Okay? You'll have multiple triangles. Some of them might even be overlapping. Okay, so it's just, we're dialing up the complicatedness a little bit, but the knowledge itself is the same. Alright. So, in this case, PQ is equal to QR. PS is equal to SR. And angle PST is congruent to angle TSR. PST and TSR. And you're going to prove that triangle QPT is equal to triangle QRS. I'm not going to rewrite the given statements because they're right here. If you want to, you can. Alright, pay attention to the triangles you're being asked to prove. I'm going to go ahead and highlight them. This is the triangle you're being asked to prove. That one and this one. You're not told a whole lot of information about those triangles. You're told a whole lot more information about these triangles. So when you're doing these proofs, if you don't have enough information to prove the triangle's congruent, start with something you can. Even though they don't ask us to prove these triangles congruent, that's where most of my given information is, so that's where I'm going to start. So focus on these 2 triangles first. What conjecture can you make first off? Well, we have a reflexive side, right? So TS is going to be equal to TS, reflexive. That's going to make side, angle, side. So this triangle is congruent to that triangle. PTS is equal to triangle RTS. Again, it's side, angle, then side. And if the triangles are congruent, then all of their parts are congruent. This side and this side are both a part of these triangles, but they're also a part of the ones that we need. So I can say PT is equal to TR because of CPC, corresponding parts of congruent triangles are congruent. So again, I proved these triangles congruent first so that I could get this side congruent to that side. I also have a reflexive side in this triangle. Which gives me side, side, side. And I've proven what they wanted me to prove. So notice in these proofs, these are all of the, I think all of the ones you're going to do today, most of the ones you're going to do today are going to be like this. You're going to have a triangle congruence theorem. You're immediately going to use CPCTC, and then that is going to give you enough information to prove another triangle congruent. So notice we have two congruent statements with CPCTC in the middle. Okay, that's what all your proofs are going to look like. Let me give you one more example. Again, like I said, the pictures are going to get a little bit more complicated. You're told that angle E is congruent to angle C. Angle AD is a bisector of angle CAD. And that's it. Okay. So again, start with your given statements and see where they lead you. Don't necessarily worry about what you're asked to prove. I will tell you you're asked to prove BD is equal to FD. But we're not going to worry about that right away. Okay? Don't start with the end. Start with the beginning. You know that that is equal to this. You also know that this is an angle bisector. If it's an angle bisector, then it splits this angle in half. That makes these two angles equal to each other. So blah, 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 given. I'm going to start with this. It tells me angle bisector, so I'm going to talk about angles being congruent. Angle CAD is equal to angle EAD. And because it's a bisector, I'm going to put definition of bisector. Okay. I also know, so now here's where I have to get creative. So I know that that angle is congruent to that one. That's all the information I have. Do I have enough to prove any of the triangles in the picture congruent? Not necessarily anything they ask for, but are there any triangles in the picture I can prove congruent? Well, I notice I have a reflexive side here. If I look at this triangle and this triangle, AD is reflexive. So AD is equal to AD. So these are much harder than what you've dealt with before. It does require creativity. It does require a little bit of an imagination. Okay. And it does require practice. Okay. Alright. So, and again, I don't really know where I'm going right now. I mean, I do because I did this proof last year, but at this point, I wouldn't really know where I was going. I would just be trying to get as much information proved as I can. Okay. Remember, if we cover up one of the triangles, which congruence theorem is that? We have an angle and a non-included side. So that's going to be angle, angle, side. Okay. We have our first triangle proved congruent. What is it that we're asked to prove again? We're asked to prove that this is congruent to that. I know that. Where did I go with this last time? Oh, yeah. Okay, I see where I'm going. Alright, so this triangle is congruent to that one. So that means all of their parts are congruent, right? And we're trying to prove this is congruent to this. If you just look at these two triangles, this side and this side share a side with these two. So that means this is going to be congruent to that one. Because of CPCTC. Okay. I also have vertical angles. So angle BDC is equal to angle FDE by vertical angles. That makes these two triangles congruent. Okay, they're going to be congruent by ASA. And if these triangles are congruent, then their parts are congruent by CPCTC. So this proof actually used the CPCTC twice. Okay? We did our triangle congruence, which gave us this part. This part led us into the next triangle. And then we had our next triangle congruence. And we ended with the part that we were asked to prove. Now, those of you that are starting to get the hang of proofs and it's starting to get kind of easy, y'all are going to love these because it's going to be kind of like a puzzle. The ones that are saying proofs are fun, these are going to be super fun for you. I understand that some people are still struggling with the basic proofs. And I understand that this is going to go way over your head at first. Be positive, be patient. I promise it will come. You're only going to work a couple of problems like these. I understand that these are challenge problems, so I will keep that in mind. I just want you to have a good attitude and try them and see how far we can get. Okay?